Okay, we want to integrate dy over y times L minus y. We're going to use partial fractions, which means we're going to take the expression 1 over y times L minus y and express it as something over y plus something over L minus y. We need to determine the constants a and b. Now, if we take the right-hand side and put it over a common denominator, and I assume you know how to do this from first year calculus. If not, review the method of partial fractions. We're going to put the common denominator here is going to be y times L minus y, which is going to allow us to match up the expression we get here with the expression we get here. We're simply going to have to set the numerators equal. Multiplying a over y by L minus y over y, we get a times L minus y over y times L minus y. And multiplying the second fraction by y divided by y, we get by over L minus y times y. We can clearly see the multiplication by L minus y over L minus y and by y over y, which, as you should know from algebra, does not change the expression, just change the form of the expression. And now we can combine the two fractions. The denominators match. The order's different here because we wanted to show why these things, how the y divides the y. But we get a times L minus y plus b times y divided by y times L minus y. And that's going to be equal to our original expression, 1 over y times L minus y, indicating then that, well, this is going to be true if the numerators are equal for all values of y. So we get a times L minus y plus b times y equals 1, again, for all values of y. If we expand this and collect our terms, we see that we're going to get b minus a times y from the negative ya and the plus yb here, plus al equals 1, meaning that since this has to be true for all values of y, b minus a is going to have to be 0. Otherwise, changing our y value would change the value of this expression. So that b minus a equals 0 and al equals 1. This has a simple solution. A has to equal 1 over L from this equation, and a and b have to be equal here. So b equals a equals 1 over L. And now our integral becomes, and let's find a little place in this paper here. So now the integral of dy over y times L minus y becomes the integral of a over y, where a is 1 over L, plus the integral of b over L minus y. So b being equal to a gives us 1 over L minus y dy. These integrals are easily done. We get 1 over L times the natural log of the absolute value of y plus 1 over L times negative natural log of the absolute value of L minus y. So there's your partial fraction integration, and of course we're going to have plus an integration constant here. I'm going to just slip that in right here. That's just our integration constant, combining the integration constants for the two indefinite integrals.